All right, eighth grade, had some technical difficulties here, and so I went through and made a second video so that way we could make sure we had all the content here. So number four, we've got number four, and then the bottom half of this page. It says a batter hits a ball. The equation for the arc of the ball is y equals negative 0.04 x squared plus 0.4x plus 2. And I went ahead and rewrote that equation here at the bottom just so it's a little easier to read. I know there's kind of some smudging and whatnot up top here. And that equation, in that equation, x represents the horizontal distance. So horizontal distance, that's left to right. That's how far out. Y is the height. So y is how up or down. So it's like the xy axis plane. X-axis left to right, y-axis up and down. How far will the ball land? So guys, what we're looking at here, ignore my bad drawing, but we got a batter here and he's hitting a ball. This arc represents how far that ball is traveling. And it represents, okay, you hit the ball up in the air and it's going to land somewhere. And what I want to know is how far will the ball land? So when this ball finally lands, say it were to, this arc were to keep going and it were to land right here. Okay, how far away from the batter did the ball land? That's what I want to know. And remember, when we find something that's in standard form, it's squared, so we should have two solutions. Well, the purpose behind this is, yeah, we're going to have two solutions, but these are what we call approximate solutions. And the book is going to refer to them as approximate solutions, and it's used a story problem similar to this one. However, I think of it more as an appropriate solution because of the solutions that you get, only one of them is appropriate and only one of them will logically make sense. So let's go through and let's solve this problem for those two solutions, and let's see which of those solutions makes the most sense. And that's going to be my answer as far as how far out will the ball land. So let's go through, let's label all of our pieces. So A is equal to negative 0.04, B is equal to 0.84, C is equal to 2. I think it's very important that you go through and continue to label those out. That way you don't make any mistakes when it comes to solving your quadratic formula. All right, let's go through quadratic formula. So x equals negative b plus or minus square root b or minus c all over. So it's all over 2a. Now we can go through and let's start plugging in our numbers. This one, guys, notice with our decimals, important that you don't skip any steps because there's a lot of room for error here. X is equal to negative b, so it's negative 0.84 plus or minus square root of 0.84 squared minus 4 minus times negative 0.04 times equal to 2. And the final step, put it all over 2a, 2 times negative 0.04. I think this is probably a good point in the video. Go ahead and pause it. Attempt to find the two solutions at this point, and then maybe hit resume or hit play on the video after you paused it and see how your answers compare to mine. All right, so hopefully you went through and you've already solved the problem. So let's go through and let's simplify this quadratic formula down. So when I simplify this, I'm going to have x equals negative 24 plus or minus. Now, again, I would recommend guys not do this in one big step. I would probably kind of separate this one out. So I have that b squared. So I'm going to have 0.84 squared. That's going to be 0.7056. And then I go through here. So negative 4 times negative 0.04 times 2. That's going to be 0.32. So plus 0.32. And this is all going to be over 2 times negative 0.04, negative 0.08. All right. Now let's go through and let's I'm going to move up top here so we have a little more room to work with. Move it all up, so I'm going to have x equals a negative 0.84 plus or minus. Square root. Combine what's underneath my square root here, 0.7056 plus 0.32. I get 1.0256. So that's going to go underneath my square root over negative 0.08. Now, there's a couple ways you can do this, guys. You can simplify this square root, which when you simplify that square root, you get this really long decimal. You can go ahead and simplify this out, or maybe another trick, go ahead and separate it at this spot right here. So I'm going to have x is equal to negative 0.84 plus the square root of 1.056 over negative 0.08. That's going to be one of my solutions. The other solution is going to be x is equal to negative 0.84 minus square root of 1.026 over negative 0.08. All right, so I've got my two solutions. Now I need to simplify those out. So on the left, x is going to be equal to, we can go through and we can type all this in. Here, let's move it to one side of our page. So again, if I type this in, so negative 0.84 plus the square root of 1.0256, I take that answer, divided by negative 0.08, I get negative 2.1, we'll round again at the hundredths, negative 2.16. All right, so x is equal to negative 2.16. Next solution, let's go through and let's solve that one. So this time, negative 0.84 minus square root 1.0256. Get this answer, divide it by negative 0.08. This time I get 23.1, we'll call it 6. So x equals 23.16. Now I want to ask, wish I could ask you guys in person, but ask yourself now, which one of these answers makes the most sense? Again, your question asked, how far will the ball land? Well, if a ball were to go any distance, it cannot go a negative distance. So it only makes sense for this x equals 23.16 to be our answer. It's the only logical or appropriate answer because it's a positive and I'm working with distance. For those of you that play baseball or maybe softball, you're thinking in your head, well, Mr. Garrett, if I hit the ball foul, technically it's not going into play. Wouldn't that be a negative distance if I hit it behind me? Well, you have an argument there. But if you're hitting a ball, it still is going a certain distance. You cannot have a negative distance. If I were to go to point A to point B, regardless of what direction I'm moving, you're still moving. The distance cannot be necessarily negative in this case. Another way to think about it is, if you hit this ball, it's almost like this is where your y-axis is. So when you're hitting it at 0, you're going to hit the ball logically forward along x-axis, so again, at 23.16. So again, x equals 23.16. So think about what you're dealing with, think about your problems, and that's going to kind of help you with some of those approximate solutions, okay? All right, last section with our notes. This time we're going to talk about the discriminant. The discriminant, we're going to touch briefly on this, guys. You really don't deal a lot with the discriminant in algebra, but for this sake, we are going to use it with the quadratic formula a little bit. The discriminant is the expression that is underneath the radical, and I shorthanded it here. It's underneath the radical in the quadratic formula. So if we look at our quadratic formula up here, it's underneath the square root. So it's going to be this b squared minus 4ac. So I even rewrote this here. B squared minus 4ac. That is what we call the discriminant. So maybe a good idea to star that, arrow it, however you want to do it in your notes. But that's going to be your formula for the discriminant. And what the discriminant is going to tell you is how many solutions or how many of the solutions are real numbers. So all of these are going to have two solutions, but how many of them are going to be physical, real numbers that we have? So in a sense, an integer, a decimal, a fraction, and whatnot. So whenever you take this discriminant, the b squared minus 4ac, and you solve it, if that number is greater than 0, you're going to have two solutions that are two real numbers. And this is what those types of graphs are going to look like. They may not always be positive like this one. They might be negative and flipped upside down, but you're still going to pass through the x-axis twice. If you were to solve the discriminant and it were to be equal to 0, well, then you're going to have one solution. It's going to pass through this x-axis only one time. So really, guys, what we're asking ourselves is, with this discriminant, how many times it passes through the x-axis. That's kind of your key here. So if it is equal to 0, it only goes through the x-axis once, and that's because it touches the x-axis at one spot. And that's kind of what those graphs would look like. And with our last one, if the discriminant were to be less than 0, well, then we would have no solutions. There are no real number solutions then. And that would mean, guys, because the discriminant is less than 0, that would mean that it is negative. So anytime you get a negative discriminant, that's going to mean that it's less than 0 and there's no real number solutions. And again, that's kind of what I was getting at in the first video, guys. You always want that number underneath the radical to be positive. So that way we kind of stay away from any imaginary numbers then. Okay, so with this section, you're going to take your standard form, find the discriminant, and then with that discriminant, you're just going to tell me then how many real number solutions it has. So let's take 2x squared minus 3x plus 5. So I'm only using the b squared minus 4ac. That's the only equation I'm using here. I'm only using like half of the quadratic formula. So let's plug our stuff in. So our b is negative 3 minus 4. What's a? A is 2. And then c happens to be 5. So then go through, solve this out. Negative 3 squared is going to give me 9. Negative 4 times 2 is negative 8. 8 times 5 is going to be 40. So I'm going to have 9 minus 40. I take 9 minus 40. I get negative 31. And negative 31 is less than 0. It's a negative number. So I have no real number solutions. All right, and that's all. That's all you're doing. You're just taking the b squared minus 4ac, and you are just solving it, positive, negative, 0, and that's going to tell you then how many real number solutions there are. So your answer for number 1 is going to be this no real number solutions. It's not negative 31. That negative 31 just tells you what the answer is. So the answer is no real number solutions. Last problem, guys, and then we'll be finished for the day. Hopefully you've been a good sport and you played along and listened to all the notes and got them all down today. So last one. So again, write the formula down. B squared minus 4AC. My B squared is going to be negative 5 squared minus 4. A is 6. C, negative 7. Go through. Negative 5 squared is 25. I know this is going to be a positive in the middle because I'm doing a negative eventually times a negative. So negative 4 times 6 is negative 24 times negative 7 is going to be 168. So I have a 25 plus 168, and that gives me 193. Using your chart, 193 is more than 0, so therefore you have 2 solutions. So with this one, your answer is 2 real number solutions. And there you go. So that's kind of a little bit with the discriminant and working with it, and just if you have any questions over the homework, kind of what that means then. All right. Last little piece of information here I did want to add. If you were to graph these guys, these last 2 questions, so the graph you're looking at right here is the same problem we just looked at with number 1, where there was no real solutions, and you can visually see how this one does not touch the x-axis at all. And if you were to go into your y equals, you can go through here and you can go through every single list of these ordered pairs, and you can even notice that, hey, y never is equal to 0. You can kind of go through here, guys, and narrow this down and know that, hey, it's going to fall somewhere where this 1, 4 is, because as you go up, we get higher. As I go down, it gets higher. So I know 4 is very close to the vertex that 1, 4 is. And again, y is not equal to 0. So again, no solutions here. We can visually see that on the graph. Same thing if you were to graph number 2, 6x squared minus 5x minus 7. We graph that one. There it is. You can visually see it touches the x-axis in 2 distinct spots then. All right. Hopefully you guys enjoyed this lesson. Again, this is one of my favorite ones in this chapter. If you have any questions, let me know. Thanks, guys.